So, with some luck, slides are projected. Welcome, it's great to be here. Thanks for the invitation to the ALASCA team. Great event, great summit. And it's good to be here again to see a room full of people that want to learn about technology and work together with us on sovereignty. Ever since ALASCA started, and even before, we've had a very, very good relationship as a large open source community. And just maybe to echo what was said this morning by Marius, it's important if we are sharing 99% of the same goals and then have like different opinions on how we maybe address a certain specific technical detail, that we still remember, let's work together on those 99%. Let's have those fight on the last 1%, but let's not mistake this to be whatever enemies and think we are the fiercest competitors and shouldn't work together. We still share a lot of common values, a lot of common technology, and certainly the Sovereign Cloud Stack community and the ALASCA communities have been working very well together over the course of the last years, and I'm glad to see that continuing, and I hope that will continue to be the case going forward. Deep dive is a bit relative, so I guess I should have asked maybe for a day workshop or something, so I can go really deep into technology. So don't be disappointed if I'm now. It says deep dive, and I'll still stay on the surface of a lot of things in that presentation. I cannot start a presentation that has the word Sovereign Cloud Stack in it without quickly saying a few things about sovereignty. So when we talk about sovereignty, we go far beyond just thinking about, well, who has control to my data, who can access it, and how can I keep my data sovereignty. We also think that it's important that you have the ability to not be dependent on a single provider, so you have the ability to switch providers, to work with several of them, to federate them even, which of course we do using certifiable standards in the SCS community. Second thing is we believe in technological sovereignty, and that means you understand the technology, you can study it, you can change it, you can adapt it, you can innovate on technology, and the only way we think you can do that is by using open source technology, and I think very much in line with what just Kai said a second ago, that open source may not be like the answer to all digital sovereignty questions, but it's a prerequisite. Without open source, you will not be able to achieve a lot with respect to digital sovereignty. And that's of course also why when we talk about digital sovereignty, we talk about software. We develop software. We need to have an implementation of the things we want to achieve. Third thing is knowledge. So without having like skilled people that know how to work on that technology, that know how to also operate that technology, we cannot be successful. And operating environments with high quality is often harder than get it to run in the first place. So that's also a focus really on the operational aspects. Quickly talking a bit about the software side of things and how we've taken decisions and architected and what actually is covered by what we call Sovereign Cloud Stack. There were a few basic decisions we did at the beginning. Well, first of all, of course, all complete open source software. And we want to do it in a way that we don't require some very special, hard-to-get proprietary hardware. Just commodity server hardware needs to do, and we need to be able to build on top of that. We have taken the decision, and that's something that I see sometimes a lot of heated discussions with various communities. We have taken the decision that running Kubernetes, which is of course the layer where you typically then start to put applications on top. Well, most of the modern applications work, of course, on top of Kubernetes. We've decided to put that on top of a virtualization platform, and that was for various reasons. One is, of course, the ease with which you can basically create Kubernetes clusters, scale them, change them, adjust them, create small ones, create large ones on the fly as a service, basically, is something that's easier if you're on top of a virtualized platform. And then the second thing is really an security isolation thinking. We've seen projects where people actually share Kubernetes clusters between different projects, different customers, we think it's good to have like virtualization isolation between them. So having a virtualization platform below that is good. And that does not say that doing bare metal Kubernetes isn't valid. I think it's valid for a lot of use cases. If you are like a cloud provider, large multi-tenancy, lots of customers, I think the virtualization platform with Kubernetes on top has benefits, and that's why we did it that way. The next decision we took is, well, I mean, let's look at virtualization and Kubernetes as a service layer separately. So you can both use them independently, but of course you can also combine them. And if you combine them, they should work extremely well together. As we worked on standards, we also said, well, I mean, it's good to discuss on standards in theory, but unless you have like an implementation that implements those standards and shows how they work, it's a bit theoretical, and it's easy to come up with some ideas what should be standardized and kind of not have like the users and the customers in mind. So doing that hand in hand is a good thing. There's one danger, obviously, if you do standards and implementation together, is that in the end your reference implementation is the only implementation that can fulfill the standards. So you need to be very careful of that and make sure you stay open and you have connections to other implementations and make sure they can work as well. So make sure you have a reference implementation, but make sure you don't treat it too much with too much preference, right? Make sure you stay fair there. And I think we've managed very well with that. I mean, we started with a reference implementation, and then later on with the ALASCA community and Yaouk, we found great support and made sure the standards are fulfilled there. Operations, I already said, that's one of the main challenges. So tooling is important, and thinking not just on the functional stack, but all the tools you need around to run infrastructure is somewhat forgotten by some projects, because it's not like the shiny things that your users see every day, it's just the things that your operators see every day. Treat your operators well. They are extremely important, skilled, and critical people. And they're also scarce. One of these things we had in mind when we say, well, let's compete with a bunch of providers that are interoperable with the large companies out there is, of course, they are much larger than we are. So we can only be successful if we work together well, and we work well together when we do open source development, of course. That's what we learned to do the last 40, 50 years, actually. We work together when we build operational tools, but let's also make sure users that use our platforms can use several of them and have them together, have them connected together well. And that's, of course, what we do with federation and federated user management. So that's an area we put quite some work on. It's probably also the area that still needs the most work. So it's more complex than you think. Building on top, of course, what's there already, open source solutions is important, so that's what we do, and of course contributing back to them rather than just doing downstream forks is important to make sure that we don't end up in a very fragmented world, but in a world where the open source projects that we all build upon thrive. Good. Okay, upstream first. I mentioned this. What is part of the software stack? And maybe I switch one slide further immediately to not eat up too much time. So that's a very classical stack where you have a virtualization platform and Kubernetes clusters on top. So it's building on top of standard hardware, putting virtualization for storage, compute, network on top of that. We expose that using the OpenStack APIs, using the OpenStack core services. And then on top of that, you have like a really nice platform to use to put Kubernetes clusters on top. So that's the center part, which is the functional stack. Pretty straightforward, but still useful to maybe put on a slide. And then operational tooling that covers all the different layers: monitoring, lifecycle management, audit, logging, billing, All those pieces need to be done, and your identity and access management also across those layers. And of course, all of that needs to be highly secure because people want to have control. How much time? I'll run through the next slides very quickly. Virtualization layer shouldn't be really a surprise for all of you. We're using OpenStack, you virtualize compute storage network, and then you have like a nice API standardized that you can automate, and everything is as a service on demand. And you can use your infrastructure as code tooling to deploy your workloads in an automated way. And you can, of course, use such a virtualization platform to host your legacy workloads. That's what some people do. You can also put cloud-native technology on top of that. But a lot of people, when they think about cloud-native technology, don't think virtualization, but they think containers. So we also have this Kubernetes as a service layer. What you see here is really the ability of creating container clusters on the fly as you need them. We are using a cluster API-based approach to that. Cluster API has a nice way of abstracting the lifecycle management of Kubernetes clusters and allows you to specify that. And we've built a bit of a framework around that with the cluster stacks and combine basically the magic of cluster API that does things like cluster upgrades, for example, or just changes to the configuration of your cluster in a cloud-native, prescriptive way, the way Kubernetes does it. We also have like the pieces around that you need, like which is node images and the what we call add-ons, which is really the cloud controller manager, networking, storage integrations, metrics, the pieces you need to have a cluster that's really useful. So that's the second layer. We have monitoring pieces in place, and I think we will hear more about monitoring from Martin in a few seconds, where he has contributed. This is like an old tool that still my own legacy, where we monitor the OpenStack control plane performance and make sure we have metrics on that. Identity federation, as I said, is the largest piece, which is still ongoing work, and I hope we can somewhat launch a project in the future soon to do some work there and maybe get this piece finished as well. Last thing I want to kind of do in this presentation is really trying to get you interested in getting your hands dirty and start using some of that technology. One of the things we have invested a lot of time on is building documentation, and also, so you see a screenshot of the docs page, docs.sovereigncloudstack.org, and also I've had the pleasure, or I should probably say the privilege, to do a Sovereign Cloud Stack training in Kenya with an international crowd, and ITU has actually agreed to open source the training material I have created for that training. So on the GitHub pages of Sovereign Cloud Stack, you also find training material, how to create and manage your own open source Sovereign Cloud Stack cloud environments. And this is like a, you can actually browse it online. It's a collection of Markdown documents. You can also create a nice PDF, which I have a screenshot of, which has like 90 pages of content on the all the layers that make up such a Sovereign Cloud Stack. And it really covers the blue pieces on here. So if you're working and want to get your hands dirty with OpenStack, of course, there's classical ways using DevStack. We've heard some good information on Taruk and Yaouk already. I think we'll hear a lot more during this conference. So I'm happy to participate and learn a bit. But there's also, of course, the classical Collar Ansible-based things we've done with support from OSISM. And getting a cloud in the box up and running is something that you can really do within 2 hours. And you have like a good development and test environment that you can use. But of course, you can use the same technology to build real clouds. And there's a number of cloud providers that are using that. This is like my home lab. I still need to find time to do some 3D printing for a cage of this, but those are like 6 little Nook-sized boxes, and they're perfectly fine to run a multi-node test cloud. One of those actually I brought with me for the workshop tomorrow with a cloud-in-the-box installation. It's like those mini computers have the advantage of not eating so much power, so you can actually run them at home. Otherwise, your electricity bills will not be as funny, I guess. Just an 8-core Zen 4, and you can put like 128 gigabytes of memory in them, and that's perfectly fine to run a little cloud for testing. And if you use a number of them, it's a really good test system. We put Ceph on that as well, with NVMEs in there. Then, of course, on the Kubernetes layer, there's many ways to do that. Cluster stacks is the solution we've chosen as the reference in Sovereign Cloud Stack, so there's a lot of documentation and training material on that. But there's also many different ways of doing that. Might it be other cluster API-based solutions, or maybe even Gardener, which now with the Neo-Nephos Foundation is finally in open governance, so that's something which now can develop in an open source way, which it unfortunately couldn't do previously, but for large scale multi-cloud hybrid solutions, that's maybe the powerful tool. At least it's rather popular in Germany. And with that, I hope I have encouraged you to get your hands dirty, play with some technology, use that, and I'll try to, well, hopefully finish in time. Thanks.